In this video we will look at the quality of our surface for surface paneling. Like we learned in my first video, basics and principal basics for surface paneling, we differentiate between two different kind of arrays. Two-dimensional array for surface paneling, which is related to the U and the V of my surface, and a one-dimensional array which is related to the amount of polygons and the position of polygons in my array. With Para3D we can work with two different kind of types of surfaces. We can work with polygon surfaces and Nurbs surfaces. So what I do right now, I just select my array from this example. I open my Para3D. Para3D is opening, and I just select my surface controller of this para node. It's not about the program right now, so don't bother, you will definitely learn this in another video. I can just choose my surface, my polygon surface. I can update, and you can just see that this surface paneling works pretty well. And just to repeat it, like in my first video, I can just change the amount of U and V, and now we have 7 items in my U direction and 10 items in my V direction. And we can also choose these Nurbs surface. I just select my surface controller again. I just choose my surface here in this menu. I click on Auto Update. And here we go, and this array is paneled on my Nurbs surface. Most of the time I work in 3D Studio Max with polygon surfaces, but Nurbs surfaces, apart from that they are not as advanced in 3D Studio Max than the polygon surfaces, have some very few nice things. And if you look at this Nurbs surface, you can just in my surface, in my display options, you can switch on ISO line only, and then you have only these ISO lines, which is a really nice way of showing this. And there's also one thing in Para3D which you can only do with Nurbs surfaces. You can choose between different kind of surfaces in my Nurbs surface. So if you have a look at this properly, you can see that in my Nurbs surface there are two surfaces actually. And in Para3D you can choose between surface name number 1 and surface name number 2. I just choose my second surface name. I go into update, and we just see that it jumps to the second surface, which is a really nice and handy feature. So let's have a deeper look into the quality of my polygon surface. And I just scroll out a little bit. I prepared some examples, and the first example I choose is this one. It's already named quad polygons, so you have to keep an eye on one thing. All my polygon surfaces have to consist of quad polygon surfaces. This means every polygon should only have 4 edges, otherwise my surface cladding doesn't work properly. The next rule you should always keep in mind with Para3D is that every object should have an edit poly modifier on all the other modifiers. And we just look at this example. This is just one simple plane, and if I just choose this plane and I go in Auto Update, it already says edit poly operation and on non-editable poly, and this just doesn't work. So I just choose this plane again, and I will add an edit poly modifier on top. Select my surface, and now we see it works properly. This is, by the way, something quite easy to forget, so always control at the end of the day that whatever you do with your polygon surface, put an edit poly modifier on top, otherwise it just doesn't work. Like I already said, if you have, for example, a surface like this with triangulated polygons, that's not really a good idea. We just choose it right now. I go into Auto Update, and it just says invalid geometry. Sometimes it works, but my objects are not paneled properly. You have definitely the chance to use triangulated arrays, but this works differently. We will learn this in further video tutorials. That's just a different kind of topic. The next example we look at is this one, and what I said is that every polygon should have only 4 edges, and if you're not really in this topology of edit poly, it looks a little bit like this, that this example the polygons have 4 edges. So when I choose this and it already has an edit poly modifier on top, I go into my select and I select this surface, I go into auto update, then it just gives me a one-time error. And when this happens, and you can see that this little bar just stops in the middle of something, you definitely have to close your Power 3D, and with right mouse click on one of these objects you have to open it again, otherwise you can't continue. So if you look at this geometry a little bit further, I just select it and I go into my vertex level. You can just see that it's not really like this. Every polygon has more than 4 edges. I just have a look at this one. It has 1, 2, 3, 4, 5. And this is also the reason why we have this error. This polygon, for example, also has 4 edges. So even if it looks straight and the edges are in the same line like these two, it's not like that these are quad polygons. So the first impression sometimes is wrong. This is definitely not working. These are no quad polygons. This example is a little bit more tricky. It looks pretty well if I select it. Okay, just select it. Then you can see that there is an edit poly on top. This is an edit poly modifier. Just renamed it, and so it looks quite well. But when I select it with my surface modifier, you can see that there is a one-time error. And there are some mistakes in the topology which you can't see at the beginning right now. If I look at this, there are some vertices just double. I'm just looking at this. Here, for example, there are 2 vertices. So what I do if I'm not really sure about the quality of my polygon, and if it causes an error, or probably I just do it anyhow, I just select all my vertices. I just selected it all with my string A, all my vertices. I go into break. So far I have 359 vertices. Select this. I go into break. I select them again, and now I have 1280 vertices. So all vertices are broken actually. When I then go into weld, my weld function just glues these vertices together again, and I just say OK in this amount of 0.1 centimeters, and I select all vertices. Then I have the same amount of vertices. I have 357, or a little bit less actually, sorry. And when I just deselect my surface and I go into my Power 3D again, I just select one of these nodes, and Power 3D is opening. Let's have to wait for a second. I select my surface modifier and then my plane, and now I go into auto update. Then we see it works properly. So there are situations where everything looks really good, but it still causes a mistake, causes an error. So one successful way is just select all vertices, break them, and weld them together. And this is sometimes just a really good way to clear up your surface. So when I look at this line again, be aware of that means this green color of my polygons. Quad polygons for surfaces, for surface paneling work pretty well. Always be aware of that you have an edit poly modifier on top. Don't use triangulated polygons, they don't work so well. Check your topology. Sometimes it looks like that it's a quad polygon, but it actually has 4 or even more edges. And even if your surface looks pretty well, it could be that this surface is not really clean, and one way is just like I already said, select all vertices, break them and weld them together again. For a two-dimensional array, you should also keep an eye on if you have any singularities. For example, this is a simple cube, and I just unfold this kind of 3D object, and we can see that in principle it's a really simple shape, but if you unfold it, you have 2 polygons, and then it goes, it has left and right an extension, and you can't unfold it in one long line. And these things are called singularities. This means here's a singularity, there are 2 edges, 3 edges meeting each other, and you should keep an eye on that. It's a little bit like looking at the map, that there's continuity in your whole geometry, and then you can use a 2-dimensional surface. With this example, you can't do it. If I just choose it and I go into auto update, it just gives me an error that this kind of geometry I can't use. But I can use it with a 1-dimensional array, just because I have polygons, and these polygons, each polygon only has 4 edges. So for a 1-dimensional array, it actually works. So what I can do, I can just choose my 1-dimensional array. That's actually this one. And if I go into my surface controller and go into pick objects and choose this one and go into auto update, you can see that for a 1-dimensional array, this situation works pretty well. When we look at this geometry, we don't even have to try this. There are 2 things. The continuity inside this geometry is broken. It just stops here, this kind of and continues again. So just keep an eye on, this is a typical singularity, that this doesn't work, especially with your 2D cladding. What also doesn't work is if you have an object with multiple surfaces, for example like this one. If I choose my 2-dimensional array and select this kind of geometry, I go into auto update. There's a result, but it's a little bit unexpected. So this is also something which you should not use for a 2-dimensional array, and actually also not for a 1-dimensional array. But of course, there's an enormous amount of variations for 2-dimensional surfaces. This is already a surface we saw. It's also interesting how the surface is built. It's just 2 simple lines attached together. Then I just use the cross-section modifier to connect these 2 lines after I attach them. I use the surface modifier and then an edit poly on top. And this is something obviously which works really well. So if I just choose my surface controller again and I just auto update, then it just sits on this kind of surface. And also interestingly, this is just a torus geometry, and this works much better with than the cube, because if I just unfold this, you can see a continuity in all directions. All lines start from the beginning and end up without any interruptions, and that's the reason why you can just choose this also for a 2-dimensional array. I just auto update it, and you can just see that it works pretty well. You can't see it so well right now. Just choose my torus not under set height selection, so we can see it a little bit better. And if I now change the amount, for example, instead of 7, I also say 10 by 10. Then you can see that you can use the torus not pretty well. And also these kind of objects, which is much more complex. It's a loft function, and Okay, the shell modifier we definitely don't need right now. And the Loft function has an added poly modifier on top, so it's a quite complex geometry. If I select this with my surface controller and I go into auto update, it has to calculate a little bit longer. But here we go, it works pretty well. It doesn't look so well right now because the setting of amount of my items is not right. So I just choose my first dimension and I just enter a really high amount of items. Okay, finished, here we go, but I made one mistake. I used the wrong dimension. I just swapped between U and V, so I just swap these two dimensions from UV to VU dimension, and I go into auto update. And there are already many objects, like 500 array objects for my paneling, and if I just choose my Loft function and I hide this, then you can see that also this one, even a really complex object already, also works pretty well with my two-dimensional array. Even my torus node, which has a continuity, works pretty well because you can cut it and slice it here in one part and just unfold it like my simple torus node. So if I just choose this one and go into auto update, it should give a decent result, and we just wait for some seconds. A lot of array objects, panel objects to calculate, and here the same issue. It doesn't look good just because we don't have enough objects in my second dimension and too many objects in my first dimension, so we just swap from VU again to UV, and I go into auto update and we wait again some seconds, and this looks then again pretty well. Okay, here we go. A really nice design of two-dimensional array surface paneling. So even if these last three examples are more than just one surface, they're already quite complex objects. They work with two-dimensional arrays, but of course also with one-dimensional arrays. And we finish this video with two more examples in terms of my one-dimensional array. I just choose my one-dimensional array again in my Para 3D settings, and I just select my cube, and this is again an unfolded cube. I select it and go back to my settings so we can have a look at the basic geometry like this cubic cube again. And this works only with a one-dimensional array. I go into auto update, and here we go. And if I look at the amount of array objects, panel objects, it's 48, so we can adjust it. We can adjust the amount of objects. I go into set array and count the number of objects, and now it's reduced. It's 42, and this is the same amount of polygons we have here with our object. Okay, the last object we look at is this kind of letter, three-dimensional letter, and what we can see is that here we have our polygons, and on top there is a polygon which much more edges than 4 edges like a quad polygon, and we just see what it does with this object. Okay, I choose both my surface controllers again. Like I already said, we look at this in another video where I will explain the functions of this surface controller a little bit more in detail. I choose my object and I go into auto update, and what we see is that the surface cladding works pretty well on this kind of surface, but obviously not so well on my top and also on my button, because these polygons are not quad polygons. So what you have to do is, if you also want to have a surface plane here, you have to tessellate them. Actually, you have to tessellate them. So if I just choose this one, I go into auto update, then it doesn't look much better, because what you have to do is you have to increase the amount of a number of polygons of my array objects, and now you can see that it has a really nice result on top and bottom. And if you have a geometry like this, and that's the last thing for my video, which happens to me quite often, there are some mistakes. I always choose all my vertex points. I just break them, I select them again, I go into weld and weld them together again, and this is normally a way, if there are any errors, we can fix these kind of things if you just see that your geometry is nice and clean. Especially for a one-dimensional array, but also for two-dimensional array, you need a little bit more knowledge in terms of tessellation. So if you're not really familiar with this, it's probably worth watching my digital design strategy videos tessellation. Okay, thanks for watching.